All right, Bismillahirrahmanirrahim. Assalamu alaikum, students. Let's start and discuss some theoretical topic about categories of equilibrium in two dimensions. And for this kind of a system, basically, as we already know, for any system to be in equilibrium, it requires some condition. If we say any body which is basically has to be a force equilibrium, okay, then it's a different condition. And if we want a body to be in complete equilibrium, we're talking about 2D equilibrium, it is going to be a different condition. Okay, if any body is required to be in equilibrium regarding it, we say it is a force equilibrium, then we will always write it as that equation as forces, summation of all the forces about that body must be equal to 0. Okay, and we can further elaborate it as it means that sigma fx must be equal to 0, and we can also write it sigma fy must be equal to 0. We are writing fx and fy because we are assuming that our system is a basically coplanar force system. Okay, this condition, for any coplanar force system, this condition will be a must, that it is, and this is your x, this is your x, and this is your y. It means it's a coplanar force system. But when we say the body has to be a two-dimensional body, has to be in complete 2D equilibrium, okay, so now we have to write the condition as this: summation sigma fx must be equal to 0. Then we can also have to write sigma fy equals to 0, and we also have to write summation of all the moments about the z-axis must be equal to 0. Okay, what do you mean by z-axis? It means that if this is our xy axis, our two-dimensional plane, then the rotation and movement about this plane will be perpendicular to this plane, about the xy plane. Okay, it will always be perpendicular. Okay, so the rotation, if we can say, if this is your x-axis, if this is your x-axis, this is your x-axis, and this is your y-axis. Okay, this is your this is your y-axis. Okay, and so rotation will always be about the z-axis, which is perpendicular to this plane. Okay, so you must always remember, this is your x, this is your y, and this is your z. Okay, so you must remember this condition: sigma fx equal to 0, sigma fy equal to 0, sigma mz equal to 0 for a body to be in complete 2D equilibrium. These conditions must be there. Okay, now after having the knowledge of this kind of a system, we can very easily proceed and try to understand this categories of an equilibrium in 2D. Okay, first of all, what is he saying? Force system. Okay, force system means group of forces which are acting simultaneously on a particle or on a system or body is said to form a system of force, said to have a specific force system. Okay, so under that category we have basically got a collinear force system. Okay, if you look at this collinear force system, this is body, if we have an and it is basically a coplanar force system. We must remember that this is a coplanar force system, but all the forces are basically collinear, means lying along the same line regardless of its magnitude and regardless of its sense. Okay, they are forming a collinear force system, and if you see, all these forces are lying on the x-axis. So for any coplanar collinear force system, we will write coplanar, we will write the independent equation for this kind of a force system will be sigma fx equal to 0. Okay, so it's not always like, if we have a system like this, if we have a system like exactly similar to like this, if we have any system which is It can be also, this is any system, okay, and basically we will say that this is our basically all the forces, and you can have, you can say this is one force, okay, this is one force, then you can have another force like this, you can have another force like this. You can call it, so you can call it as say P1, P2, P3. Now still it will be a collinear force system, and if we say this is our x-axis and this is basically going to be our, this is going to be our y-axis. So now this is x-axis and this is y-axis. Now what will be the independent equation for this system? It will be sigma Fy is equal to 0, because all the collinear forces are lying and parallel along the y-axis, and they are all basically lying along the same basically line, so they are called collinear forces. It does not matter, their magnitude can be different. So this is basically the condition, most important condition for a force system when you write an independent equation after seeing the system. And for this collinear force system over here, an independent equation is sigma Fx equal to 0. There will be only one independent equation for the collinear force system. It can either be sigma Fx equal to 0 or it can be sigma Fy equal to 0 over here. Okay, so this is over here we have brought sigma Fy equal to 0. Okay, so practically if you want to see any practical example of a force system is basically again basically if there are two groups of students and they have a rope and they are playing and they are trying to stretch this rope along towards themselves. Okay, so this is an example of a collinear force system. Okay, so if you want, you can simulate it something like this. Okay, this is, you can simulate this system like this. Okay, and like this. Okay, whoever wins, it will not be someone will always win. Okay, this is P1, this is P2. This is a very good example of a collinear force system. This is a collinear force system. Okay, now we proceed to a concurrent force system. Okay, if you look, it's a concurrent force system at a point. Okay, and again this system, they have drawn x and y axis. X and y axis, what does it means? That this force system will always be lying along x and y plane. So we will always call this a coplanar force system. Okay, coplanar concurrent force system at a point. This is point O. If you look, all these forces are basically converging at this point O. Okay, so for this again, if you look this F1, if you just look at F1 will always have, if you want to resolve this, it will always have two components. If you look, it will always have two components, like this is going to be Fx and the other component will be Fy. Okay, if you look, same with this F2 will always have two components. Okay, one component will be like this and the other component will be like this. So in order to write this kind of a force system equation for this, we will have to basically for independent equation we have to say sigma Fx equal to 0, because these forces could be resolved along the x-axis and it can also be resolved along the y-axis. Okay, so we have to write this independent equation as sigma Fx equal to 0, sigma Fy equal to 0. Okay, but if you look again very critically, all these forces are converging at this point O. So at point O, F1, F2, F3, F4, if we cannot have a basically moment over here because there is no moment arm, so we cannot basically sum that moment about the z-axis because they are all converging. There is going to be no moment arm about the z-axis. Okay, so whenever you write a concurrent force system at a point, you will always use these two independent equations to express a coplanar concurrent force system at a point. Okay, again remember, when xy comes for any system, you will always have to think into mind, it is coplanar. It is coplanar because of xy axis on that plane. Okay, so you have to write sigma fx equal to 0, sigma fy equal to 0, and if you want to see a practical example, okay, you can see this riveted basically structure is there, okay, in which we have got it's called a gusset plate, and again basically we are using basically four different types of forces are there, 1 2 3 4 5 different types of forces, and if you look, these forces are all converging at a single point, and you can call that point as O. Okay, F1, F2, F3, F4, F5, whatever it is, these are all converging at a single point. So it will be forming a coplanar concurrent force system at a point. And for this force system, the equation, independent equation, always you will going to use is sigma fx equal to 0, sigma fy equal to 0. It is very important when doing the numericals, you have to see what kind of a system, force system is being given to you in a numerical. It is a collinear force system, you will use this equation. If it's a concurrent force system at a point, coplanar concurrent, you will use these two equations. Okay. Now we go to the third one, which is a bit more typical. It's called as a parallel force system. Okay, parallel force system, if you look at it, all the forces over here, F1, F2, F3, F4, if you draw the free body diagram of this system, are along the x-axis. Okay, so we will be using, since all these forces are along the x-axis, they are parallel, they are not collinear. Okay, they are parallel to the x-axis, so we have to use this equation. We have to use this equation, sigma fx equal to 0. Okay, if these forces were lying along, if this force is lying along the y-axis, okay, then in place of sigma fx, you will use what? You will be using sigma fy equal to 0. So if you have any body, okay, and all the forces are something like this. This is one force, you have another force like this, you have one force like this. Okay, so if a system is expressed like this, okay, these forces are parallel to the y-axis. So now instead of using sigma fx, you will use sigma fy equal to 0 and not sigma fx, just from the generic point of view. So you don't have to learn that it's always sigma fx. It can also be, for this system you will be using what? You will be using sigma fy is equal to 0. Okay, we will be using this sigma fy is equal to 0. Okay, so you know very well. Now they have used another equation, sigma mz is equals to 0. Okay, this is very typical. Why they are using this kind of a system, sigma mz equal to 0? Because if you look at, just for this, if you look this f1, f2, f3, they are all parallel to the x-axis. Okay, and for this FPD diagram, this system that we have, okay, let us say that we constrained or pivot this body at say at this point. Okay, at this unique point. Okay, at this point. Okay, if we pivot this body, so f4 is passing through this point, so there will be no moment arm. But if you look very clearly, okay, basically you can have an if we say this is the point, okay, Now this is the pivot. Now look what is this happening. This force, okay, this force, there is basically some perpendicular is passed through here, so there will be some momentum. This force over here, okay, if you look at it, it will have some sort of a momentum. We can see it more clearly if you see, we draw this body, okay, and we say these are our forces, okay. Okay, and we basically say draw some sort of a pivot point here, okay, and you know it very well that this is going to be one force, there is another force, and this is another force, okay. So if you look at it, this force, we say this force as P1, this force as P2, and this force as P3. If you look at it, there the momentum of this force about this point O is 0. So this force nullifies, it vanishes. But if you look at it, basically this force, okay, if you look at this force, okay, it will have some finite momentum, okay, it will have some finite, which is this. If you look at this force, okay, if you look at this force, it will also have a, this will have this momentum through point O. If you look at it, okay, force times the perpendicular distance, force times this momentum or perpendicular distance, and if you look at it, this is our x-axis, this is our x-axis, and this is our y-axis. This is our x-axis and this is our y-axis. So if you again look at very carefully, this force, okay, P2 and P3 has the tendency to rotate this body about O, and if you look at it, it has a tendency to rotate this body about the z-axis, and that rotation you can very easily say it is going to be about the z-axis, and it is a clockwise rotation of this body because of P2 and P3. P1 vanishes. If this point is another unique location, then P1 will also come into action, but we are saying that point O is passing through P1, so it zeros, and these two forces will try to create rotation about about this point O. So we can say this rotation will be about the z-axis, and it's a clockwise rotation. That is the main reason that for writing an independent equation for a coplanar, I am using again coplanar y, x and y. X means in a single plane, coplanar along this plane. So it will be sigma fx equal to 0, and you will always use summation of moments about the z-axis equal to 0. So this will help you a lot to understand this force system, the collinear force system, the concurrent force system, and the parallel force system, okay. And again remember, all these force systems are coplanar, okay, in a single plane. Now we go to a more tricky force system, which is a general force system, okay. General force system, again this is again a coplanar general force system, okay. And again, why coplanar? You see, they are always not writing coplanar but writing xy coordinate system, which means it's coplanar, and xy coplanar, okay. Just to let you, for your enhance your further knowledge about this, if I use the word, I say non-coplanar, if I use non-coplanar, so what kind of a coordinate system will come to your mind? If I say non-coplanar, you will say that it will have x, it will have y, and it will also have z, okay. So this is a non-coplanar force system, okay. So always remember this unique point, it will be very helpful to you. So a general force system is basically a coplanar general force system will have different forces, okay, different forces along F1, F2, F3, F4, all of them will be coplanar, okay, lying in this plane, and but it will have one unique moment, okay. This moment will basically be lying about the rotation, has a tendency to rotate this body clockwise about the z-axis, okay. So you can say whenever a general force system in which you have different forces in a coplanar system are acting and there is also a moment, then that is a general force system. So I want to give you an example. If you look at it, this is number 4, this is number 4, okay. You can see concurrent force system, this is number 2. A parallel force system again is basically, this is number, if you see, this is a parallel, this is number 3, okay. So for a general force system, if you look at it again, if you have a beam, okay, and you have basically a beam in which you have a pin and a roller, but you can see this force is basically along the y-axis, this force is along the y-axis also, okay, and basically there is a moment also, okay, there is a moment also, and there is a loading over here, okay. So and if we also basically over here add another force, we can, if we add another force over here, okay, we say this force as 5 Newton, 5 kilonewton, okay. So there is a force along the x-axis, there is a force along the y-axis, okay, and then there is a moment, okay. So this is an example of a general force system, okay, in which you can have a force along the x-axis, you can also have a force along the y-axis, and if you want, you can make it, you can also have a force, like this also. You can also have a force like this. You also have a force like this. It is angle, making some angle, say 30 degrees. Say it is making an angle of 30 degrees, and you say it is 10 kilonewton. So again, this force will have components along the x-axis, it will have components along the x-axis, and it will also have the components along the y-axis. This will be the horizontal component, and if you look at it, this, there will be another component of this force, okay. This will be the vertical component along the y-axis, okay. So again, force along the x-axis, force along the y-axis, force making an angle theta will have two respective components along the x-axis, y-axis. There is loading also, which will also have some resultant, okay, you can calculate, and again there is a moment. So this is basically an example of a general force system in which you have to use sigma fx equal to 0, you have to use sigma fy equal to 0, and again you have to use, because of this moment, you have to use summation of all the moments about the z-axis must also be equal to 0, so that this system, now to solve this system, a general coplanar force system, you will always be using these 1, 2, 3 equations, okay. For a parallel, again, if you look at it, I have given you practical examples. If you look at an aeroplane, okay, if you look at an aeroplane, and an aeroplane, again, if you look at it, this is going to be the center of gravity. This is going to be the center of gravity of this aeroplane, and again all these forces, the PTH force, the PZ forces, okay, they are basically forming a parallel force system, okay. And if you look at it through this center of that point, these forces have the tendency to create rotation, of this aeroplane. This force P8, this is the moment arm of this force. PZ, this is the moment arm, and again it has a tendency to rotate it. That is why for a parallel force system, for this, if I ask you to write equations, you will write it's a coplanar parallel force system, and I say what will be the equation for this system, you will automatically write it as sigma Fy is equal to 0, and you will also, because of this moment about the z-axis, you will write sigma mz is equal to 0, okay. So I hope you have understood this topic of categories of equilibrium in 2D, okay. With these practical examples I have shown you, and I would like to thank you all and inshallah I will come up with another video for you guys. But in the meantime, you have to subscribe my channel so that I will be sending you more knowledgeable videos about statics and its fundamental concepts. Thank you.